Welcome to this video. It gives an overview of the RF couplers and power dividers design and simulation software from rfhammer.com. Save the exe and the icon file to your PC and it should run on all standard Windows 10 machines. The first window which opens is this one, where you can select between various options for couplers and power dividers. Note these are lumped couplers and lumped power dividers, or they use discrete components. So we have couplers with a 90-degree phase shift. We have the standard branch line or the 90-degree hybrid coupler. We have the coupled line 90-degree coupler, and then we also have a branch line coupler with only two inductors. Couplers 180 degrees, we have the standard rat race coupler, and then we also have a coupler which is a branch line coupler with a phase shift. Power dividers, we have a Wilkinson power divider, equal power division, and we have a Wilkinson power divider with unequal power division. Then we have a Gysel power divider, and you can use this software for equal or unequal power division. Let's open then the couplers 90 degrees of branch line. So this window is open and we can run it. Okay, so we see we have four windows here. The first window is the input, so you can input all your parameters over here. Here we have the frequency response simulation of the coupler. We can select between coupling, match and phase. Over here we have the circuit diagram. You can see it has four inductors in this case, and here we have the component values for the coupler. Okay, so frequency standard coupling. Okay, so we can vary the coupling. We can have a 10 dB coupler. So let's make this 10 dBs and we can run that, and we see we end up with a 10 dB coupler. You can see here's the coupling, the 10 dBs. We can also have a lossless case, lossless inductor, so just make your inductor Q very large. Then we have a lossless case. So over here we can see then we have an exact 10 dB coupler. Okay, so we also have the advantage where we can then open simultaneous windows. So let's put this one over here. We put this one here. Okay, so let's have a look at a branch line with only two inductors. Okay, let's run that one. Okay, let's also make this a lossless case with a high Q. Let's run that again. Okay, so here we have the two cases. Over here we have the coupler 90 degrees with only two inductors. We see we only have two inductors. And over here then we have the case of four inductors. So we can compare the case, the various characteristics of the couplers. You can see in this case the coupling doesn't really have a bandwidth which is too large. Let's also make this 10 dB coupler. Okay, so this has quite a slope on it, so your amplitude imbalance is going to be worse for this case, the two inductor case, than for the four inductor case. But two inductors is perhaps a good option if you don't want to use a lot of inductors. Okay, so we can then have a look at the match as well. We can look at the phase as well. Okay, so that's a nice option to have, where you can then compare designs and simulations. The coupled line case, so we have the coupled line case. Once again, we can vary the coupling. In this case, the output ports are at port 2 and port 4. So if you have an application where you want the ports not together on the same side but on opposite side, you can perhaps consider this one. This is basically based on the standard distributed coupled line coupler. Okay, so let's close this one and let's go to the couplers 180 degrees. So we have the standard rat race Then the branch line coupler, 90 degrees, branch line coupler with a 90 degrees phase shift, which will give us a 180 degree coupler. Standard rat race, once again we can vary the coupling, so we can make this any coupling we want. Okay, so there we have a standard 15 dB coupling rat race. We can once again make the Q very high for the lossless case. And then we have a 15 dB coupler shown by S41. Okay, so this is in port 4 as a coupled port. Okay, this is in where you just have a branch line and you just put a 90 degrees phase shift on the output, and then you can also simulate a 180 degree coupler in this way. Let's have a look at power dividers. So we have the standard Wilkinson equal power division. So that's standard Wilkinson power divider. We have Wilkinson unequal power division. Okay, so here we have the unequal case. Now in this case we have P3 over P2 ratio. There's port 2 and port 3. So let's just make this once again a lossless case. Okay, so what does it mean if we say 6.02 dBs? In this case that means the difference between S21 and in this case S31, that's going to be 6 dBs. Okay, so the difference then between those two lines is going to be 6 dBs. This is what then this ratio P3 over P2 means. So obviously if we want to have an equal split power divider, we would make that 0 dBs, which is basically 1, and then we have a equal split power divider. Okay, then we have a Gysel power divider. What is a Gysel power divider? Okay, you can see it has a much more complicated circuit diagram. What would be the advantage of this power divider? Well, the only advantage is where it is often used is where you would want your resistors down to ground. So the normal power divider has resistors which are not on ground. So if you're working with a high powered application where you want to heat sink your resistors, then this is perhaps an alternative, as the resistors can be well heat sinked as they are actually then grounded. Okay, so once again we can also then change the power division or power split, make that 3, and we see then the difference between those two lines is going to be 3 dBs. Okay, so those are the various options you have for the lump couplers and power dividers from rfhammer.com. Thank you for watching this video, and remember to visit rfhammer.com. There's lots of other software available there. Thank you.